Okay, so let us continue, students. Before I move ahead, I'll quickly show you all how a thermogram looks. Okay, you all must have seen this before. Okay, so these are nothing but thermograms. All right. So I don't know, like I even in depth I don't know, but maybe such certain kind of this thing indicates a certain kind of color indicates something. So it all depends on your heat radiation, how much heat is radiated. Okay, Sanskriti, I'm so sorry, dear. I think so I missed out your name. Okay, okay, but I'll mark you present. Don't worry. Okay, all right. So as I was saying, yeah. So the if any organ, okay, it is defected or some disease is there, it will radiate less heat, and we can understand it with the help of a thermogram. Okay, so these are nothing but thermograms. All right, students. Now, actually, one thing that is there, as I told you all last time. Actually, I told you all last time, and then today. In the first half, I did not open this page actually. So this is actually the bifurcation of radio wave, students. ठीक है, मैंने बोला ना radio waves that are there, the very first category of EM waves also they are bifurcated inside to many categories. Like see, VLF stands for very low frequency. LF, you all know there was one use UHF in radio waves के अंदर एक use है. It has UHF written in it, ultra high frequency. Okay. So see, this is the radio spectrum. It is known as radio spectrum. It is radio waves का spectrum. जैसे इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम है पूरा, वैसे ये रेडियो वेव्स के अंदर का स्पेक्ट्रम है. अगेन एक्स्ट्रा इन्फॉर्मेशन, there's no need to remember this and all. I just wanted to tell you all that something like this exists. Okay, fine, all right. If you all want, you all can take a screenshot and keep. But again, as I suggest, don't need to memorize all the frequency range and everything. Okay, don't need to do that. You all have main focus is your electromagnetic spectrum, not radio spectrum. Radio waves is one part of electromagnetic spectrum. Okay. So if you all want, you all can take a screenshot and keep, or if you all simply search on the internet, you all will get. Okay. Fine. So let us continue with the chapter then. Let me go to the textbook quickly. Okay. Now, students, we have finished IR, infrared. Okay. Now, the next type of this thing is visible light. Now, visible light is something that you all know, okay, already. Just 1 minute. Yes, Saurav, I asked you to resend it, right? As soon as the session begins, copy paste everything and resend, I told you, right? Now, wait till I finish explaining. Wait. Okay, fine. All right. Now, what is visible light, students? See, it is the most familiar form of EM waves. These waves are detected by human eye. That is the reason visible light. Therefore, this wavelength range is called visible light. The visible light is emitted due to atomic excitation. Okay. Properties, different wavelengths give rise to different colors. You all can see this, your Vibgyor that is there. Okay, so basically, I don't know why they have not written indigo over here. You all know, right? Vibgyor is the abbreviation for rainbow colors. Okay, so indigo is not there, but apart from that, all other are there. So violet, blue, green, yellow, and the wavelength. Again, this table very much important. Please star mark this table and keep. You all have to remember these ranges that are there. You all can see the ranges they have written it in nanometers. Okay, nano stands for 10 raised to minus 9. Okay, fine. So different wavelengths give rise to different colors. Refer to this table. Visible light emitted or reflected from objects around us provide us information about those objects and hence about the surroundings. Anything else is written regarding this? Okay. See, students, I hope you all know this concept that why do leaves appear to be green? Because they reflect green color. Okay, out of all the 7 colors that are there, they absorb all the remaining colors, but they reflect the green color back, and that is the reason the green color falls into our eyes, and we think of leaves to be green. Okay, this is the concept. You all must have heard this before also. Okay, fine. So the color that is reflected is the color that we actually see. Okay, fine. Next, we go for ultraviolet rays. Again, UV rays सुना रहेगा बहुत बार. What it is, we'll see that. Okay, ultraviolet rays were discovered by J. Ritter in 1801. They can be produced by mercury vapor lamp, electric spark, and carbon arc lamp. Okay, so I'll quickly show you all what these things are. Okay, fine. But first, let us quickly read what is written ahead. Okay, students, see to it that you all mark these things, okay, like where they are produced and everything. Basically, I can give you 4 options and ask you all to find out which is the odd out of the 4. Okay, so if there is mercury lamp, electric spark, carbon arc lamp, okay, all these things, they do produce UV rays, okay. But if there is some fourth option which does not fit the criteria, it does not produce, okay. They can also be obtained by striking electrical discharge in hydrogen and xenon gas tubes. Okay. So what I want you all to do is that I want you all to note down what is the meaning of electrical discharge. Okay. What is this electrical discharge? I want you all to write it down somewhere over here. Okay. So write electrical discharge, put a colon and then write down what I'm dictating. Electrical discharge is the release and transmission of electricity. Electrical discharge is the release and transmission of electricity in an, okay. Electrical discharge is the release and transmission of electricity in an applied electric field. Release and transmission of electricity in an applied electric field through a medium such as gas. Through a medium such as gas. Okay, I'll repeat. Electrical discharge is the release and transmission of electricity in an applied electric field through a medium such as gas. Okay, so it's basically transfer in a gaseous medium. So you can actually see sparks that are there. I'll show you all some pictures so you all will get an idea. So that is what electrical discharge is. So you all can see one way of obtaining UV rays is by striking electrical discharge in hydrogen and xenon gas tubes. Because that is what electrical discharge means, right? It is transmission of electricity through gaseous medium and we have to apply the electric field. Okay, so that is what the meaning of striking electrical discharge is. Now, if I quickly show you all the objects that are there. Okay, just a minute. Okay, so first we'll see what a mercury vapor lamp is. It looks somewhat like this. Okay, fine. I think so. This green, see, there's a demonstration video also. So you all can search on YouTube if you all want. So these are nothing but mercury vapor lamps. Okay, fine. If I have to read a little bit about it. Okay, there's the explanation. Okay, you all can see over here. This statement you all can see. A mercury vapor lamp. What is a mercury vapor lamp? Which is used to produce UV rays. Mercury vapor lamp is a gas discharge lamp that uses an electrical arc through vaporized mercury to produce light. Okay, so basically vaporized or I can say gaseous form of mercury is used to produce light. Okay, which will eventually give me UV rays. Okay, fine. So now, what is an electrical arc? Okay, one person has said something. Okay, gas discharge tube structure of atom mein hai. So you all must be knowing this then already. Yes or no? If it was already explained to you all what it is. Okay, fine. So mercury vapor lamp is an example of a gas discharge tube. Okay. So students, you all know, right? Like you all know what an electric arc is then. Or you all know what a gas discharge lamp is, right? So there's no need to explain. Mercury vapor lamp is one of the example of gas discharge lamp. Okay, fine. Then another thing that produces UV ray was electric spark. Okay, so electric spark, as the name says, this is nothing but electric spark. Okay, you can see the diagrams. All right, so if I have to read a little bit about it, see, an electric spark. Just one second. Okay, an electric spark is an abrupt electrical discharge that occurs when a sufficiently high electric field creates an ionized electrically conductive channel. Basically, electric spark is nothing but your electric discharge only, little bit more intense. Okay, fine. All these are used to produce UV rays. Then what is a carbon arc lamp? Okay, So here are some of the diagrams I can say, or maybe real devices also they have put up some pictures of carbon arc lamp. Okay, fine. Now, if I have to read a little bit about this, let me see if some simple this thing is there. Explanation. Okay, so carbon arc lamp is also one of the examples of a gas discharge lamp, just like your mercury vapor lamp. Okay, fine. So again, no need to see the explanations and everything, like in-depth applications or mechanism of how it works. We don't have to get into that. Okay. So just simply remember, mark all these things. What are the devices that produce UV rays? Okay. Let us read ahead. Sun is the most important natural source of UV rays. Okay, you all know this. Sun se UV rays aata, to it is one of the most important natural source of UV rays. All these things are like what man-made, right? Mercury vapor lamp and all this electric spark, carbon arc lamp to produce UV rays, but we naturally also get UV rays from where? From the sun, which are absorbed by the ozone layer of the Earth's atmosphere. Okay, which is not good. All right, fine. So because of excessive absorption of UV rays, what is happening? Ozone layer protects us from the UV rays that are there. But depletion of ozone layer is causing what? The UV rays to directly reach the Earth's surface, which is not good. And why the depletion is happening? Because of chlorofluorocarbons, because of the pollution that humans are emitting. Okay, let's read the properties. They produce fluorescence in certain materials such as phosphorus. Okay, so see, what are phosphors? Students, all can write it down. Just quickly write it down. Okay, write the word phosphor and then write down. Phosphors are materials that emit light when exposed to radiation. Phosphors are materials that emit light when exposed to radiation. Phosphors are materials that emit light when exposed to radiation, such as UV light. Such as UV light. So these are materials that will show fluorescence, or I can say they will emit light when UV rays are incident on them. Okay. So phosphors are materials that emit light when exposed to radiation such as UV light. Okay, so the fluorescence effect that is there. Okay, fine. Basically, that's UV rays, they cause photoelectric effect. Now, actually, students, you all will be studying photoelectric effect quite in detail. I think so. See, after this chapter, your semiconductors chapter that is there, it is continued in your 12th standard as well. So in that 12th standard, we have certain applications related to photoelectric effect. I'll tell you all what photoelectric effect is. Okay. So any material that is there, if UV rays are incident, basically UV rays means light, right? If sun is the natural source of UV rays, basically it is light. Light is absorbed and electrons are emitted. That is what photoelectric effect is. Okay. See, the word photo, whenever the word photo comes into picture, it is associated with light. It is associated with photons. Okay. So absorption of light will result into emission of electrons. Okay, and that is nothing but photoelectric effect. Next, they cannot pass through glass, but they pass through quartz, fluorite, and rock salt, etc. They possess the property of synthesizing vitamin D when skin is exposed to them. Okay, fine. So these are some of the properties of UV rays. Now let us see some of the uses. UV rays destroy germs and bacteria, and hence they are used for sterilizing surgical instruments and for purification of water. Okay, one I can say day-to-day application used in burglar alarms and security systems. Okay, fine. So they are used in burglar alarms and everything. Used to distinguish real and fake gems. Used in analysis of chemical compounds. Used to detect forgery. All right, fine. So UV rays are basically a lot of day-to-day applications are there in UV rays. Okay, so sterilization, then to detect whether the gem is real or fake. Okay, fine. All right. Now, next rays that we have is nothing but X-rays. Okay. Let us quickly start reading. German physicist W. P. Ronton, okay, discovered X-ray rays in 1895 while studying cathode rays, which is a stream of electrons emitted by the cathode in a vacuum tube. What are cathode rays? Cathode rays are nothing but electrons emitted by cathode in a vacuum tube. Okay. X-rays are also called as Ronton rays because he discovered it. So you all have to remember this. Okay. What if they ask in MCQ, or maybe in that one sentence they can ask X-rays are also known as dash. Okay. X-rays are produced when cathode rays are suddenly stopped by an obstacle. So in a vacuum tube, the electrons that my cathode is emitting, that is known as cathode rays, and if they are stopped, if they are obstructed, that is when X-rays are produced. Okay. So where is the properties? Okay. Now, what are some of the properties of X-rays? They are high energy EM waves. They are not deflected by electric and magnetic field. X-rays ionize the gases through which they pass. Okay. I hope you understand ionize, the meaning of ionization. Okay. Forming ions. All right. They have high penetrating power. Their overdose can kill living plant and animal overdose. Can kill living plant and animal overdose tissues and hence are harmful. So basically, exposure to X-rays for a lot of time is not good for living things. Okay. What are uses? Useful in the study of structure of crystal. X-ray photographs are used to detect bone fracture. You all know this application already. X-rays have many other medical uses such as CT scan. X-rays are used to detect flaws or cracks in a metals. Now, inside the metal, if there is a metal block and if there is a crack inside, I cannot see it with my naked eye, right? So, X-rays can be just like how your X-rays are used to detect fractures, or they, if any problem is present in our bones. So, similarly, X-rays can also be used to detect cracks inside metal. Okay, inside. Then these are used for detection of explosive and opium, etc. Okay, fine. Now the last one finally is gamma rays. In my निकलता है तो dangerous हो सकता है ना. सौरभ is asking, human निकलता है तो dangerous हो सकता है ना. क्या निकलता है तो सौरभ? X-rays you are telling, right? I mean it is see the X-ray that you remove, that is necessary, right? अभी fracture वगैरह पता कैसे चलेगा? This is what we have. But prolonged exposure is not good. You all cannot go and sit there entire time under the X-rays. That is not good. Okay, that is harmful. Prolonged exposure is harmful. Little bit exposure is, that is now mandatory. Okay, now we don't, maybe if some advanced technology comes where X-rays are not needed, some other things will be needed, then harmful nahi hoga. Okay. Last is gamma ray, students. This is the sign for gamma, like how you all have alpha, beta and everything. So similarly gamma. Okay. All right. Discovered by P. Willard in 1900, gamma rays are emitted from the nuclei of some radioactive elements such as uranium and radium. So you all can mark this. Okay, they are emitted from the nuclei. That is what alpha and beta rays are as well. Okay, such as uranium, radium, etc. They are highest energy EM waves. Okay. Now here see the energy is denoted in the terms. This is a unit, electron volt. Okay. This EV that is there, EV is a unit called electron volt. K stands for kilo, capital G stands for giga. So you all, that notation is going to be same. Okay. So you don't have to worry about that. But what is the energy range for my gamma rays? From kilo electron volts to giga electron volts. Okay, fine. Giga means it is going till 10 raised to 9, which is in the positive, right? So that is the highest energy EM waves out of all the EM waves. They are highly penetrating. They have small ionizing power. They kill living cells. Okay. What are the uses? They are used as an insecticide disinfection. So they are used as insecticide disinfection for wheat and flour, used for food preservation, used in radiotherapy for the treatment of cancer and tumor. They are used to produce nuclear reactions. Okay, fine. So with this, we are done with the electromagnetic spectrum. Now from the next part, students, the propagation of EM waves. The next topic is there. This has now involvement of my communication system. Student, communication system means basically we'll be seeing about transmitter and receiver and how the waves are transmitted from one place to another and all those things. So what we can do is we can divide the chapter into two halves. So till here, till electromagnetic spectrum, till gamma rays, your next test is going to be. So you all have to see these solved numericals that I've already discussed with you all. Okay. Yeah, students, another homework for you all is just go through this table. This, just 1 second. Uh, 1 second, students. Okay. Yeah. So just go through this table. Okay. There's the marker or this generated by column is they are summarizing everything whatever we have studied till now. Like how microwaves are produced by oscillator electric circuit, gamma rays are produced because of the nuclei of radioactive materials. So all those things they have written in one sentence over here. Okay, fine. Now see students, electromagnetic spectrum, one more thing, remember the order. Okay, you all have to go in this order only. You all can either write from radio waves to gamma rays or you all can go from gamma rays to radio waves, but the order has to be systematic. Okay. Another thing, if you all get an answer on electromagnetic waves, okay, like electromagnetic spectrum. So I'll give you all a 4 marks answer. Explain electromagnetic spectrum. So you all will explain everything, okay, how it is formed. You all will give uses. You all will give properties. You all also have to give the frequency or wavelength range. According to me, frequency range is very mandatory. You all can write both as well. Okay, you all can write both because as I said, if you all remember one, other one you all can easily find. But giving frequency range is mandatory. Okay, so if you all are writing about radio waves, your first statement should be the frequency range of radio waves in hertz, or you all can write the frequency range, whatever the value is, and without fail, write down hertz beside it. Okay, fine. So that is important. That is something I wanted the answer from you all, even in your exam, not only classes test, but even in your exam. So you all have to see these numericals that we have already discussed. You all have to see the 6 numericals that we discussed from behind the textbook. And from start of the chapter till this gamma rays part, you all have to read everything properly. Okay.